This final example of probability is going to be utilizing a mean wait time between two independent events. So this is the function that we're going to utilize to model the wait time. So we're going to have mu e to the minus x over minus x divided by mu. And mu is going to be the average time, or the mean wait time. X is going to be the actual wait time, which we don't know, of some sort of given random event. So let's say at a certain restaurant we have the mean wait time to be seated is 15 minutes and the mean wait time to receive your food is going to be 20 minutes. Assuming that the probabilities are independent, find the probability that a person goes to the restaurant and waits a total of more than 45 minutes before receiving their food. Alright, so there's two events going on here. Let's define x to be the number of minutes of actual wait to be seated. Sorry about that. So the mean number of wait, the actual wait time to be seated, and let's let y represent the time or the number of minutes to receive the food. Right. So in this case, the model, and let's just assume that x is greater than or equal to 0 because we can't have negative time. So let's just say that f of x is going to be equal to, since it's 15 minutes on average to be seated, that's going to be 15 to the minus 1 e to the minus x over 15. Right? And that's going to represent the time, or the model, the density function for the minutes to be seated. Now, I'm going to call g of y a secondary function, and g of y is going to be equal to, we have our mean of 20 minutes, so that's going to be 20 to the minus 1 e to the minus y over 20. And so if we get a function that multiplies those together because we want the joint density of those two, then we have a function of both the time necessary to be seated and the time necessary to receive the food. So I'm just going to call that, let's call it h of xy. Right, that's going to be our density function essentially. That's going to be 15 to the minus 1 e to the minus x over 15 times 20 to the minus 1 e to the minus y over 20. All right. Now we can simplify this expression very nicely. We know that 15 to the minus 1 times 20 to the minus 1 is going to be 1 over 300. Right, so if we simplify this just a little bit, we get 1 over 300. And then since we have a common base of e, we can multiply, or we can add the exponents together, so we just end up with an e to the minus x over 15 minus y over 20. So that's our function. Now what we'd like to do is we'd like to be able to find the bounds of this function. All right, so the problem asks us to be able to find the probability that somebody waits more than 45 minutes. All right. Generally with a density function, you can find the probability of less than a given value. So let's do that, and then we can try at the end to manipulate that a little bit. So what we know is that x plus y is going to be, now we want to say greater than 45. Let's just right now have it equal to 45. All right, that's going to give us the boundary, which in turn would give us a linear function, and the linear function is going to be y is equal to 45 minus x. If we graph that, that's what we get. Slope of -1, intercept of 45. So down here at the intercept we have the point 45, 0, and then up here we have the point 0, 45. And the reason we need this is because this is the region that's going to determine whether we have a type 1 or a type 2 integral. It's going to help us to set up the double integral, and then we're going to be able to evaluate the double integral. If I think of this as a type 1 region, because we already have y equals 45 minus x as our function, let's just think of this going up and down. It looks like the lower function is 0, so y equals 0 is the lower function, and then the upper function is y equals 45 minus x. So y is going to range from 0 to 45 minus x, and then x is going to range from 0 to 45. All right. So coupling all of this together, we're going to end up with a double integral. And so our double integral is going to be integral from 0 to 45 minus x, 0 to 45. Remember our function, 1 over 300, and then we have e to the minus x over 15 minus y over 20. We took care of dy first, so this is going to be dy, since we went up and down first on in our graph, and then dx. All right. Now, to be able to evaluate this, we would use a u substitution. What I'm going to do is I'm going to throw this into a computer algebra system to be able to get to our solution. So using a CAS, what I found was that the probability was approximately 0.7278. Now, unfortunately, this is not the probability that we're looking for. This is the probability under the curve. All right, so this is the probability underneath. All right, so we don't want that probability. We want everything that's greater than that. All right, so let's understand what this represents. Okay, this is the probability of less than 45 minutes. Okay, to be able to get the probability of more than 45 minutes, remember that the total probability is 1. So to get the probability of more than 45 minutes, what we're going to do is we're just going to take something called the complement. We're going to take 1 minus 0.7278. Remember, 1 is the total area, so we always subtract from 1 to be able to do a more than type of problem. And if you could verify this, I'm going to do this in my head, this is going to be 2728. Okay, 0.2728. So roughly about a 27% chance that if the mean wait time is 15 minutes, and then the mean wait time to get the food is going to be 20 minutes, the probability that you're going to wait more than 45 minutes is about 28%. So it's not extremely likely, but again, it is possible that that could happen.